All right, so diving into some Java today. Senior level stuff, right?
Yeah, we're going deep on data structures, specifically arrays and array lists, stuff you absolutely got to know inside and out if you're aiming for that senior software engineer title.
For sure. That's one thing to just like use them in your code, but at the senior level, they want to see that you really get like the underlying mechanisms, the performance implications, when to pick one over the other, that kind of depth.
Totally. So let's start with arrays, kind of the fundamental building block, When you're declaring an array of integers, for example, what are some of the common ways you'd see that in Java code?
Okay, so I know the basic syntax is something like int numbers equals new int 10. Yeah. That creates an array called numbers reserve space for 10 integers.
Exactly. That's the classic way. It allocates the memory up front, sets it aside. You can also initialize an array directly with its values, like int primes 2, 3, 5, 7, 11, 13. That's handy when you know the contents right off the bat.
Right, and the size of the array. In that case, it's just determined by how many elements you put in those curly braces.
Exactly. Now, once you've got that array, how do you actually grab a specific value from it?
This is where indexing comes in, right?
You got it. And here's the key thing to remember. Java uses zero-based indexing. It trips some people up. So in our primes array, if you want that first element, the number 2, you'd access it with prime 0. The last element, 13, would be at primes 5.
So it's like the index is offset by 1 from what you might intuitively expect.
Yeah, it takes a bit of getting used to, especially if you're coming from languages where indexing starts at 1. But in Java, 0 is the hero. Now, what about when you want to work with every element in the array? Do you always have to mess around with those indices?
I seem to recall there's this thing called the enhanced for loop. Is that what you're getting at?
Yep, that's the one. Also known as the for each loop. Much cleaner when you just want to process every element without needing to know its exact position. You'd write something like, for int n numbers, do something with n.
So in there would just like automatically take on the value of each element in the numbers array, in sequence.
Exactly. It makes your code way more readable when you're dealing with simple iteration. Now, here's a potential trap that senior devs need to watch out for. What happens if you try to copy an array just by using a plain old assignment, like setting one array variable equal to another?
I have a feeling there's more to it than just like duplicating the data.
You're right to be suspicious. In Java, if you do int numbers equals primes, you're not making a new array. You're just creating another reference that points to the exact same array in memory. It's like sticking two different labels on the same box.
So if you modify an element through one of those references, it changes the original array too.
Precisely. If you then do numbers 5 equals 42, you'll find that primes 5 is also suddenly 42, because they're both pointing to the same data. In a multi-threaded environment, that kind of shared reference can lead to some nasty surprises if you're not careful. Race conditions galore.
Okay, so simple assignment is just about references. What's the proper way to make a genuine, independent copy of an array?
The go-to method is Arrays.copyOf. You'd use it like this. Int copied primes. You'd use it like this. Int copied primes in racing. Arrays.copyOf Race primes. The primes.length. This creates a brand new array, same size as the original, and copies all the individual elements over.
So now you can modify copied primes all you want, and the original primes array remains untouched.
Exactly. At a senior level, understanding this distinction between shallow copies like the reference assignment and deep copies like using Arrays.copyOf is super important, especially when you're designing systems with shared data structures. Gotta know how to avoid unintended side effects.
Makes sense. Okay, so we've talked arrays. Now let's switch gears to array lists. How do you typically declare and initialize those in Java?
You start with something like ArrayList-string friends, new array list. That creates an empty array list called friends that's designed to hold strings. Notice the string part. That's crucial.
Yeah, that's the generics thing, right? It tells Java what type of objects the array list can contain.
Exactly. It's all about type safety, preventing those accidental type mismatches that can really mess up your code. A big deal for maintainability, especially in larger projects. And while we're on the topic of best practices, a senior engineer should also be thinking about the initial capacity of an array list.
Right, because unlike regular arrays, array lists can grow dynamically. But doesn't resizing come with a performance cost?
It does. If you have a rough idea of how many elements you'll be adding, it can be a good optimization to set an initial capacity. It can reduce the number of times the array list has to resize itself behind the scenes. Now, how do you actually add elements to an array list, and how do you access them later?
Well, I'm guessing it's not done with square brackets like with regular arrays.
You're right. With array lists, you use methods. The add method is your friend for adding elements to the list. And to retrieve an element at a specific position, you use the getIndex method.
Still using zero-based indexing, I presume.
Always. Consistency is key in Java, but that whole indexing isn't always necessary, especially if you just want to process every element.
So that enhanced for loop, the for each loop, that works with ArrayLists too, right?
Absolutely. It's super versatile. You can iterate through an array list of strings just like you'd iterate through a regular array for string name friends. System.out.println name.
So the variable name would just take on each string value in the friends list, one by one.
Yep, that's the beauty of it. Simple and clean. Now remember how we talked about the dangers of assigning arrays directly? The same trap exists with array lists.
Oh, right. So if you do ArrayList string people, friends.
You're not creating a new array list. You're just creating a new reference that points to the same array list in memory. Same problem, same potential for unexpected consequences.
So how do you make an actual copy of an array list where the data is independent?
You use the ArrayList constructor that takes another array list as input. So it'd be var copied friends, new array list friends.
Yeah.
That creates a whole new array list, separate data, and copies all the elements from the original friends list.
Got it. Now, what if you need to move between these two data structures? Like you've got an array, but you want to get its contents into an array list, or the other way around.
You can definitely go back and forth between them. To copy an array into an array list, you'd use something like var friends equal new array list of names, where names is your string array.
Interesting. So list.of_names creates a kind of temporary list from the array, and then the ArrayList constructor uses that to populate the new array list.
Yep, that's how it works. Now, going the other way, from an array list to an array, it's a bit more, let's say, historically nuanced.
Historically nuanced, what do you mean by that?
Well, you use the toArray method of the array list, but you have to provide an empty array of the correct type as an argument. So if friends is your array list string, you do string names, friends.toArray, new string.
Why the empty array? That seems a bit odd.
It's a quirk that goes back to older versions of Java. The empty array essentially tells the toArray method what type of array to create. It's a bit of a legacy thing, but important to know. Now, there's a specific wrinkle when dealing with primitive types and their wrapper classes.
Oh, right, like int versus arrayless integer.
Exactly. You can't just directly convert between those using the same constructor approach we saw before. Java generics are designed to work with objects, not primitive types.
So you can't have something like ArrayListant.
Nope, that won't fly. You have to manually loop through the int array, box each primitive int into an integer object, and then add those integer objects to the array list.
Makes sense, given the limitations of generics and primitive types. All right, the material also goes into some common algorithms you often need when working with arrays and array lists. What are some of the essentials?
The arrays and collections classes in Java are your best friends here. They provide a bunch of handy methods, like for initializing, you can use arrays.fillNumbers, 0, to quickly set all elements of an integer array to 0. And similarly, collections.fill fills an array list of strings with empty strings.
Super useful. What about sorting? Seems like that comes up all the time.
Absolutely. Arrays.sort names will sort a string array in place using a super efficient algorithm. And collections.sortFriends does the same for an array list.
Are there any performance considerations there, like which one is faster?
Well, for really huge arrays, Arrays actually has a method called Arrays.parallelSort that can split up the work across multiple processor cores, potentially a big speed up. But that parallel sorting isn't available for array lists.
Interesting. So if you're dealing with massive amounts of data and sorting is a bottleneck, using a regular array might actually be advantageous because of parallel sort.
Exactly. It's those kinds of subtle performance insights that can really impress an interviewer at the senior level. Now, for debugging or just getting a quick visual representation of your data, what are some good options?
I remember there's a method to get a string representation of an array. Is it Arrays.toString?
You nailed it. Arrays.toString primes will give you a nice formatted string like 2, 3, 5, 7, 11, 13. Super handy.
And for array lists?
Array lists have a built-in toString method that's automatically used when you print them with system.out.printle, a KEN. So you usually don't need to call it directly.
Right. Right. Are there any algorithms that are kind of like unique to array lists, things you can't do as easily with regular arrays?
The collections class has some cool methods that are specific to lists, like collections.reverseNames will reverse the order of elements in an array list, and collections.shuffleNames will randomly shuffle them. You don't have those exact operations for arrays.
Good to know. Now let's get into the more advanced stuff. Multidimensional arrays, those are essentially arrays of arrays, right?
That's the gist of it. In Java, you can have an array where each element is itself another array. It's like a grid or a table. Like you can have int square 16, 3, 2, 13, 5, 10, 11, 8, 9, 6, 7, 12, 4, 15, 14, 1, which creates a two-dimensional array of integers.
And how do you access individual elements within those nested arrays?
You use two indices. The first one picks the row. The second one picks the element within that row. So square 12 would give you the value 11 in our example.
Okay, I'm starting to visualize it. So it's like rows and columns.
Exactly. And since each row is itself an array, you can do things like swap rows by just swapping the array references. Now, if you don't know the initial values beforehand, you can create a multi-dimensional array using new, like int square equals new int 44.
Right, that creates a 4x4 array, all initialized to 0. But I seem to remember that in Java, the rows don't all have to be the same length. Like you can have jagged arrays.
You're absolutely right. Each row can be a different length. That's useful for things like representing Pascal's triangle, where each row has a different number of elements.
How do you typically iterate through the elements in a multi-dimensional array? Nested loops.
Nested loops are the standard way. An outer loop for the rows and an inner loop for the elements within each row. You can use regular for loops or enhanced for loops. Both work fine.
And for debugging, is there a method like Arrays.toString that can handle those nested structures?
Yep, there's Arrays.toString. It'll give you a nice formatted string representation of a multi-dimensional array, no matter how deep it goes.
Awesome. Now, what about the concept of multidimensional array lists? Is that a thing in Java?
Not directly. There's no built-in type for a 2D array list, but you can kind of simulate it by creating an array list where each element is another array list, like ArrayList integer.
So you'd have to build it up manually, adding each inner array list to represent a row. It's not as straightforward as with arrays.
That's right. Now, one last thing the material mentions is command line arguments.
Oh yeah, how do arrays come into play there?
So when you run a Java program from the command line, any arguments you type after the program name are passed into the main method as a string array.
Right, so it's like if you run Java my program arg1 arg2, those arg1 and arg2 values become elements of the args array in the main method.
Exactly. It's a common way to provide input to a Java program.
Okay, this has been a super comprehensive look at arrays and array lists in Java. From the basics of declaration and initialization all the way to multi-dimensional structures and command line arguments. For anyone prepping for a senior level interview, the key takeaways are: understand the fundamental differences between arrays and array lists, know how to copy them correctly to avoid those nasty shared reference problems, and get familiar with the power tools in the arrays and collections classes.
Absolutely. And at the senior level, it's not just about memorizing facts. It's about using that knowledge to make smart design decisions, like knowing when an array is a better choice than an array list, or understanding the performance trade-offs involved in copying. That's what sets a senior engineer apart.
So, as you continue your interview prep, here's a thought. Imagine you're designing a system, maybe a big scalable system. When would you choose an array, and when would you choose an array list? What factors would you consider? That's a great question to ponder to really solidify your understanding.
Definitely. And good luck with those interviews.
Thanks for tuning in to the deep dive, and best of luck to you all out there on your journey to becoming senior software engineers. We'll catch you in the next episode.